So once again, welcome to DTech YouTube channel. So I think you have watched my all videos and subscribed my channel. So today we are going to talk on Floyd Warshall algorithm. So this Floyd Warshall algorithm is used to it's an algorithm. It's a dynamic algorithm. Dynamic algorithm to find the shortest path between all vertices present in a weighted graph. So, what do you mean by a dynamic program algorithm? So, dynamic program algorithm is simplifying a complex problem into sub parts so it can be easily solved. So, first thing, Floyd Warshall algorithm is a dynamic programming algorithm. Second, Floyd Warshall algorithm can be used in both directive and indirective ways, but not negative cycles. So, Floyd Warshall algorithm can be used in both directive and indirect graph. Floyd Warshall algorithm can be used in both directed and indirected graph. This algorithm uses each vertex in the graph as pivot checks. If it provides the shortest way to travel from one point to another point. And to solve this, we are using matrix. So, it is solved using adjacency matrix representation of a graph. And this cannot be used in negative cycles, but both negative and positive weights can be contained in these graphs, and this Floyd Warshall algorithm used to solve both negative and positive weights. So from Floyd Warshall method, Floyd Warshall algorithm can be used for both positive and negative weights. Not as Dijkstra algorithm. In Dijkstra algorithm, only positive weights can be used, but in Floyd Warshall algorithm, both positive and negative weights can be used. And Floyd Warshall method is used for finding all pairs in the find all the pairs, find the shortest pairs. So let's see in our next part how this Floyd Warshall algorithm works. So in this chapter we will learn how this Floyd Warshall algorithm works to identify the shortest distance using an adjacency matrix. So this is a graph that these are the vertex, these are the paths. So the specialty in this graph shows the direction towards specific vertex. 3 to 2 direction is this side. So this is a directed graph. Okay, directed graph. So first we must construct a weight matrix for this graph. If there is no path between these vertex, we mark their value as infinity. So this is the way to construct a matrix for weighted matrix for this graph. So initially we use D node distance node and we draw matrix. So to identify whether the matrix is 4 by 4, 2 by 2, we can use the number of vertex. From the number of vertex, we identify the matrix, whether it is 4 into 4 or 3 into 3. So there are 4 vertex. So the matrix is 4 by 4 matrix. And I name them according to vertex name. 2, 3, 1, 2, 3, 4. So I have marked vertex names in row wise and column wise. So now I am going to complete this step. So initially, first step, diagonal. In the diagonal of the matrix, we always use 0. Always use the diagonal of the matrix 0 because from one vertex to one vertex to from one vertex to itself the path is 0, not given. So we usually mark 0 as the value of the diagonal because there is no path from vertex to itself. Though there is a path, it is always 0 because it reaches toward itself. So always when you mark a path or direction from vertex to itself, then its distance is 0. Then let's take first row, then column. 1 to 2 path. 1 to 2 path value with weight is 9. 1 to 2 path. Weight is 9. Then 1 to 3. 1 to 3 path, the weight is -4. And 1 to 4, there is no direct path. So if there are no specific path, as I told, we use infinity. Then we will check for the vertex 2. So from 2 to 1, there is a direction. It is 6. its weight is 6. From 2 to 1 there is a direction 6. And 2 to 3 there is no direct path. Though there is 3 to 2, but from 2 to 3 there is no path. So its weight is infinity. Then 2 to 4. 2 to 4 there is a directed path 2. Then for the third vertex, from 3 to 1 there is no direct path, though there is 4 to from 3 to 1 there is no directed path, but from 1 to 3 there is a path. So there is no path from 3 to 1, we mark as infinity. So from 3 to 2 there is a direct path, so it's 5, mark as 5. Then 3 to 4, 3 to 4 there is no direct path, we have though we have path from 4 to 3, there is no path from 3 to 4. Then we mark as infinity. Then for the fourth row, fourth vertex, 4 to 1, 4 to 1 there is no direct path, so we mark as infinity. Then 4 to 2 there is no direct path, though there is a path from 2 to 4, there is no path from 4 to 2. Then it also mark as infinity. Then 4 to 3 there is a path, so it is 1. So this is our initial point or the initial matrix. So for all the other parts we use this for the next. So then we use find, then we find shortest distance from 1 to these following vertex. From one vertex to these following vertex we next identify the shortest path. So in this case we are using another matrix called D1. D1 means that we are starting from matrix 1. Matrix 1. So as previously said, this matrix also been marked as 3, 2, 4. 1, 2, 3, 4. So we are using the vertex 1. So for this matrix we are using the base matrix not, because each time the base would be k minus 1. If k is 1, then the base should be 0. So this is the base of this matrix. So as we are using 1, we are using this column 1 corresponding row and column of 1. We are using corresponding row and column in the base class as the active column and row in this class. So same values same values mentioned in here. So in base class we had firstly I had told diagonals always 0. Diagonals always 0 because there is no path toward each step. Then we fill a corresponding row and column in vertex 1. So 0, then 6, then infinity, then infinity. So the row 9 minus 4 infinity. Infinity. Then we have fill these other parts. How we can fill? So we have path. We are going to find path from 2 to 3. We will find the path from 2 to 3. So path, we are using this formula. D naught path from 2 to 3, 2 to 3, D naught path from 2 to 3 greater than path D naught path from 2 to 1 plus D naught path 2 to 3, 1 to 3. So we are using base class and intermediary we use 1. So D naught 2 to 3, D naught 2 to 3, 2 to 3, D naught 2 to 3 is infinite. Greater than D naught is our base class, 2 to 1, 6 plus D naught plus 1 to 3 minus 4. Then infinity greater than my 2. So we always use the minimum distance as the answer. So according to this, the minimum is 2. So D1 2 to 3, the answer minimum path is 2. Then we find 2 to 4, shortest distance from 2 to 4 through vertex 1. That's why always we mark this from path 2 to 3, from 2 to 1 and 1 to 3. The path is we are going from 2 to 3 through 2 to 1 and 1 to 3. So we are using this 1 as the intermediary or the between path in this. So next we are finding 2 to 4. So 2 to 4. Then how do we mark? D naught 2 to 4 greater than D naught 2 to 1 plus D naught 1 to 4. So we need to go from 2 to 4 through 1, then 2 to 1 and 1 to 4. Though there is no path, we can use infinity. So let's see. D naught 2 to 1, it's 6. Plus D naught 1 to 4, it's infinity. Greater than D naught 2 to 4. 2. Then 2 greater than infinity. From this, the minimum is 2. So our value, our shortest distance from 2 to 4 is 2. Then third one, 3 to 2, distance from 3 to 2. Then 3 to 2 means 2 to 1, 1 to 3. 1 and 1 to 3. So distance from D naught 3 to 2. 3 to 2 is greater than D naught 3 to 1 plus D naught 1 to 2. So D naught 3 to 2 is 5. 5 greater than D naught 3 to 1 is infinity and 1 to 2. So 9. 5 greater than infinity. So minimum is 5. So the answer here is total distance is 5. Then 3 to 4. D naught 3 to 4 greater than D naught 3 to 1 plus 1 to 4. So D naught 3 to 4. 3 to 4 is infinity. Greater than D naught 3 to 1 is infinity. And 1 to 4 is also infinity. So minimum is also the infinity. So here the answer is infinity. So I think infinity. So I think as he said, you can complete this part. So I had done it. So the answers would be 1 and 0. The answers will be 1 and 0. So now we have identified for any vertex, if you travel from from one vertex to another vertex through 1, you can get this matrix, the shortest distance matrix through 1. So next we need to identify moving from one vertex to another through 2, vertex number 2. So now we need to find the distance through matrix through the 2. So 1, 2, 3, 4. 1, 2, 3, 4. So all these diagonals are 0. So now we had the k value is 2. So our base class is k minus 1. That means our base class is this one. Now the current base class is this one. This one is our current base class. So then we are using the 2 as the path between. We are using 2 as the path between. So from this base matrix, we are selecting corresponding row and column of 2. Corresponding row and column 2. That is corresponding row and column 2. So we have 9. We have snort 5, 1. Then row wise we have 6, not double 2. So then we need to complete the rest of this. As previously, now we need to find the path for this. That means our base class is D1. From D1 1 to 3 is greater than E1 1 to 2 plus D naught D1 2 to 3. So we want to go from 1 to 3. If we go through to 1 to 2, 2 to 3. So so now our x class is this. So d1 to 3 is minus 4. Minus 4 greater than d1. 1 to 2 is 9 plus d1. 2 to 3. 2 to 3 is 2. Minus 4 greater than 11. So the minimum is minus 4. So 1 to d1 to 3, the minimum shortest distance is minus 4. Then as same, we can use to find 1 to 4. If you use 1 to 4, if you need to go 1 to 4, we can use 1 to 2, 2 to 4. Then 1 to 2, 2 to 4. So d1, 1 to 2, 1 to 4 is infinity. Greater than d1, 1 to 2, 1 to 2, 9, and 2 to 4, 2 to 4 is 2, 11. So infinity greater than 11, so the minimum now is 11. 11 is minimum. So as this, you can continue this process to complete this matrix. So I have solved. The answers are 1, 5 naught, 7, 12, 6, 1. 12, 1, 6. So this is the values. These are the values we get after completing our second one. So this process is continue and continue. So finally, we are going to matrix D4. Finally, we are achieving path D4. D4. If, as previously, we used the same method to calculate the values in D4 also. So now we are using 4 as the intermediary path. Now the base would be, so now if this is k, the base value should be k minus 1. So the base would be 3. So I have completed this graph. So the answer would be 0, 1, minus 4, 3, 6, 6 not 6 not double 2, 11, 5, 11, 5, 0, 7, 12, 6, 6, 1, 0. So this is the final output we get. This is the final output we get. Shortest ways we can go to this vertex to these points to 1, to 2, to 3, and to 4. So the formula finally, the formula for this is to find d k I j equals minimum value of the k minus 1 I k plus the k minus 1 k j. For as example, if we use this, we need to find d1 D1, 1, D1, 1 and 3. You need to find 1 and 3. D1, I is 1, J is 3 equals minimum dk minus 1 means if k is 1, dk minus 1 is d naught. I is now d naught. I is 1. K value is now what? K value is 1 plus k minus 1 is again naught. K is 1, J is 3. So 1, 1 and 1 to 3. So this is the formula for all these processes what we have done here. So initially, finally, to find Warshall algorithm says this algorithm can be solved using this algorithm. From this, we can identify the shortest path from any of these vertex to a specific vertex. From any of these vertex to specific vertex. So this is a bit complex, but I think you have got a brief idea on this. If you have any question, comment down. So this is the end of video on Floyd Warshall algorithm. So thank you guys for watching my video. Please share it, subscribe to my channel. So we will wind up for today and see again with a new chapter or a new video. So thank you guys. See you.
අයියෝ උත්තෝ විනාඩි 30යි